Hey everyone, so today we are going to be using a P2.5 RGB LED Matrix along with an ESP32S3. We'll be first of all setting up the hardware and wiring, and after that we'll be moving on with a few examples. First of all, we'll display some basic text on the RGB panel. After that, we'll write a program to display YouTube subscriber count. And lastly, we'll see how to display GIFs on the RGB panel along with some robotic eyes. So yeah, let's get right into it. Now, in order to help you with the hardware connections, I'll be sharing this GitHub repository as well. Here you have the images which will help you in the hardware connections. First of all, the default connection wire that comes with the panel. In this image, you'll be able to see which color is which wire. So on the panel, we will have this small part over here, and it has all of these connections that we need to make. Red one, blue one, red 2, blue 2, green, ground, all of these different connections. And this image helped me in identifying which color wire belongs to which connection. Now secondly, we have the pinout of ESP32S3, so that way in the connections, when we see that a pin, let's just say, needs to go to a specific pin of ESP32S3, we'll be able to see the pins over here. Now just with these two images, the pinout and this image, you'll be able to make the connections. And if you go in one example, let's just say RGB panel examples, the basic example, you'll be able to see the pins that I have defined on the ESP for each individual connection. So for example, R1 pin, I am taking it to the 19th pin of the ESP. So if I go back, that simply means that this is the R1 connection. This brown wire will need to go in 19th pin of the ESP, which would be over here, this one. Now I have followed these images to create all of my connections, and once again you can reference the code to see which pins I have used to make the connections. Now with those connections made, the next thing we need is a power supply. So in my case, I'm going to be using this 66 watt power supply, and as you can see that it is able to provide up to 4 amperes of current. So what I'll do is I'll grab a simple USB cable, plug it inside of the power supply, and the other end of the USB cable I will be connecting with the default power cable of the RGB matrix. I've done it this way. Now this is certainly not the most secure way to do it, but for the purposes of demo this will do. And of course the other side of the power cable is plugged into the panel, and with that the connections are ready and we can move on to the software part. Now for the software part, I'll be using VS Code with PlatformIO. So we'll start from scratch. I'll open up my VS Code and come to the PlatformIO section. If you do not have PlatformIO installed, you can come to the extensions tab, search for PlatformIO, and this is the one. I already have it installed, but you can install it from here if you do not have one. Then I'll be coming to the PlatformIO section. I'll click on open and create a new project from here. Now we'll need to define a name. I'll just say RGB Matrix, and we'll need to select a board. Now in our case we have an ESP32S3, so I'll be using this one for the system's Gen 4 ESP32, because it also has support for ESP32S3, which is the one that we are using. With that, we'll click on finish. It will take a couple of seconds and our project will be loaded. Now inside of the project we'll have one main.cpp file inside of the source directory where we'll be needing to upload the code. With that, let's move on to our first example, which is to display some basic text on the RGB matrix. So I've shared all of the examples in the GitHub repository, so I'll delete this code from here. I'll go to the GitHub repository. Inside of the RGB panel examples, I'll be using the basic example first of all. So I'll just copy this one. I grabbed this from a YouTube video where a guy was displaying some basic text on the RGB matrix. So I'll just paste this over here. First of all, let's fix the library issue. So we need to install this library. For that, we'll go to PlatformIO. Let me just copy this part. We'll go to PlatformIO, libraries. I'll search for this library. Okay, so here it shows up. I will click on this and add it to our project. So our project is RGB Matrix. Okay, I'll click on add, and this should install the library in our code. So if I come back over here, the error is, it should now be gone. So the error also seems to suggest cannot open source file Adafruit GFX-H. So we'll see if we can install that one as well. We'll go to libraries, search for this one, Adafruit GFX library, and we'll also add this one to the project. This is our project. We'll add this and we'll see if the error is now fixed, which seems to be the case. So the error is now fixed and we can use the code. Now, one more thing to notice here is that in these pins, I have changed the pins for G1 and B1 and G2 with B2. It's because of one problem that I have also mentioned in my GitHub repository, is that in some panels the blue and green colors are shifted. So initially when I made the connections and I ran the code, instead of the blue color, the green color was lighting up, and where there was supposed to be green color, blue color was showing up. So the way I solved that was I simply shifted the pins, which you'll be able to see here inside of the connections. But these are the pins for the connections. If you follow these with the ESP32 S3, you'll be able to have the exact same setup as me. Okay, so with that, our code is ready and we can flash this inside of our ESP32 S3. So what I'll do is I'll grab a USB-C to USB-C cable. I'll plug one side of it inside of the MacBook, the other side inside of the ESP32 S3. Now once the connection is made, I'll come over here and I will select the right port, because once again you might have a mouse, keyboard or other screens connected, so we'll need to select the correct port. I'll select that. I'll build the code to make sure there are no errors. The build was a success, and with that I'll just push the code to the ESP32 S3. Okay, once that is done, all you need to do is press the reset button, which is the small button over here, and the code will be live. So right now my power supply is providing it power, and you can see the text being displayed on the matrix. Alright, so with that, the example 1 is finished and we can move on to example 2. Now once again, for the second example, I have provided the code inside of the GitHub. So we'll go to RGB panel examples, and for the second example we'll be using YouTube sub counter. For this one, we'll be showing the YouTube logo as well as the current number of subscribers of your channel on the RGB matrix. So I'll copy this code, I'll come over here and simply paste this. Now in this code, first of all, a library issue once again. So we'll go to the libraries, search for this one, back, search for this library, and we'll install this right here, Arduino JSON. Add this to our project. This is our project. Okay, and with that the error is gone. So we have all the dependencies and libraries installed now. Now for this code, you need to add a few things. So you will need to add your YouTube API key, data API key version 3, your channel ID, your Wi-Fi name, and your Wi-Fi password. Now instead of going through all that process in this video, I'll be adding that step-by-step process in the GitHub. So what I'll do is I will add the process over here, so below this part, so you'll be able to get your data API key and all of the required things, but I'll just simply add them here for now. Alright, so I have added the credentials here in the code. So what I'll do is I'll simply push the code once again like we did the last time. So I'll build this. Okay, the build is successful, so we'll now push the code. Alright, so once the code has been pushed, I will turn on the power supply to make sure the RGB matrix has the right amperes that it needs, and then I'll click on the reset button, and with that we should be able to see our YouTube subscribers. Alright, so with that done, we'll be moving on to the next example, which is displaying an animated GIF on the RGB matrix. So I have shared the code for that in the repository as well. Once again, we will go to the panel examples and we'll go to the GIF example, and once again we'll just copy this code, paste it over here. We'll see if there is any library that we need to install. We'll copy that, same process, go to libraries, back here, paste the library, and we'll install this. So we have all of the dependencies now installed. Now in the case of this GIF example, we cannot directly paste a GIF inside of our source directory. Instead, what we'll be needing to do is we'll need to create a new folder called data, and inside of here we will need to paste the individual raw frames from the GIF. So we'll be needing to convert the GIF into individual raw frames. Now what I've done is I've already written a code, a Python code that can do that. So the code is over here, Python GIF converter. So this is the main.py code. It's a very simple code that takes in a GIF and outputs the desired raw frames. Now in my case, my panel is 64 by 32 pixels, so I'm resizing them to 64 by 32. Whatever the GIF is, I'm resizing that. In your case, depending upon your panel, you can change the resize over here. So what I'll do is I'll open up this code in VS Code, new window, GIF converter. This is the one. I have some GIFs over here. Let's just say the GIF of this mountain over here, and I'll need to convert this into its individual frames. So what I'll do is I'll come over here to the main.py, and in the input I will give it the name of the GIF, which is mountain.gif. I'll open up the terminal and I'll activate my virtual environment. So source venv/pin/activate. So now my virtual environment is activated, and inside of this virtual environment I have installed the package with simple pip install pillow. Right, this is the package that we need to install. I have also shared this requirement in the requirements.txt over here. So pillow, this is the one that we need to install. I already have it installed with pip install pillow. And with that, what we can do is inside of the frames, yes, this is empty, so we'll do python 3 main.py, and what it should do is it should take in the mountain.gif and convert this into its individual frames. So what we'll do is we'll copy all of these frames and we will paste them inside of our data over here. So paste. Right, once we've done that, now we need to close these terminals. Now inside of a new terminal, we would need to write PlatformIO. I must have the command over here, this one. So PlatformIO run -- target upload fs. This is how we need to upload the code to the ESP. One more thing that you want to make sure of, this is the frame delay. So between each individual GIF, each individual frame of the GIF, how long it should last. So that's the frame delay. The frame count is just the number of frames. So we have 3940, so we have 40 frames in total, so I've written 40 over here. Everything else is pretty simple. So what we'll do is I'll set up the ESP to upload this code. Once we have uploaded the code, I'll make sure that the power supply is turned on so that the panel can draw power from it, and I'll click on the reset button, and the frames of our GIF should now display on the panel. Now similarly for the last example, I'll just use this robot eyes GIF over here and I'll convert this into the frames. So I'll just delete all of these frames. Change the name to the name of the GIF I want to use. So it's eyes 2. I'll make sure that the virtual environment is activated, and I'll run the script once again, and we'll have the new frames. So this time we have 17 frames in total. So I'll copy these frames. I will go to the other code, and inside of the data I'll delete the old frames and paste the new ones. So with the new frames here, I'll change the number of frames to 17. And with that, once again, we'll push the code and you'll be able to see the GIF running on the RGB matrix.